Your own AI agents might be the most dangerous things on your network. In 2026, many organizations have deployed autonomous agents with admin-level privileges to databases, email servers, and APIs, and they've never revoked the over-permissioned service accounts those agents inherited. OWASP calls this excessive agency, and it's the kind of mistake that gets someone fired. We're talking agents that can delete production tables, forward sensitive emails, or drain cloud resources, all because someone thought just give it full access was easier. Machine identities have exploded. Dr. Zero Trust Research and Cloud Security Alliance reports confirm that the number of non-human identities, service accounts, API keys, workloads, and now autonomous AI agents has surged far beyond what traditional IAM was built for. Yet the same sources warn that zero trust controls cover only a fraction of these identities. We're staring at a massive gap between the growth of autonomous agents and the security rigor applied to them. NIST SP 800-207 defines the foundation. All data sources and computing services are resources that must be secured. Every communication, regardless of location, must be encrypted and authenticated. Access is per session, not persistent. Dynamic policy evaluates context continuously. Monitoring never stops. Devices and systems maintain security hygiene. And finally, collect and use information to improve security posture. These 7 tenets haven't changed, but in 2026 they now apply to every AI agent call. The old castle and moat model assumes anything inside the perimeter is safe. But AI agents often live in cloud VPCs and still get overtrusted. With zero trust, there's no such assumption. Every call from an agent to a database requires a valid, verifiable identity. East-west traffic between microservices is encrypted with mutual TLS and must pass policy checks. No more trusted internal network fallacy, especially when a single compromised agent could pivot everywhere. AI agents aren't one-shot. They run in a continuous loop. Observe the environment, reason with an LLM, take action by calling tools, then observe the feedback and repeat. This self-reinforcing cycle means an overprivileged agent can do damage at machine speed, making instant, irreversible decisions across your stack. Zero Trust must insert verification at every loop iteration, not just at login. But here's the part. Almost everyone gets wrong. Securing AI agents isn't about stopping hackers. It's about stopping your own agents from burning down the house with too much power. The OWASP Top 10 for agentic applications spells out the risks. From excessive agency, where an agent can delete data without approval, to over-reliance, where we blindly trust agent outputs. Each one has a concrete fix. Human approval gates, output sanitization, per agent IAM. If you're building AI agents, this list is your new security checklist. In February 2026, the Cloud Security Alliance released the Agentic Trust Framework, the first standard that maps zero trust controls explicitly to multi-agent systems. It mandates continuous trust scoring for every agent, strict identity governance treating agents as non-human employees, and full activity auditing with immutable logs. If you're deploying swarms of agents, this framework isn't optional advice. It's the baseline for governance. Here's the reality. Non-human identities vastly outnumber human identities in the modern enterprise. Service accounts, API keys, workload identities, OAuth tokens, and now autonomous agent credentials, most unmanaged and unmonitored. The Cloud Security Alliance and NIST both emphasize that we've shifted from managing human identities to a complex ecosystem of machine identities. If you're still doing IAM for people only, you're already behind. Picture this: a static API key hard-coded in an agent's config that never expires and has full database access. A leak compromises everything. Now compare that to an ephemeral JWT with a 5-minute TTL, scoped to a single read operation and cryptographically bound to the agent's spiffy identity. Even if intercepted, the damage window is tiny. This isn't a best practice, it's table stakes in 2026. The NIST AI Risk Management Framework provides a risk-based cycle that aligns naturally with Zero Trust's continuous verification. inventorying agent capabilities, applying governance, and triggering remediation when anomalies are detected. This is the operational safety net that keeps agentic AI from becoming a liability. In January 2026, the NSA released updated zero-trust implementation guides that, for the first time, explicitly extend the five-pillar model to autonomous agent workloads. The identity pillar now demands unique non-human identities for every agent. Device enforces posture checks on the runtime environment. Network requires micro-segmentation so agents talk only to approved destinations. Application workload adds granular per-app policies, and data enforces classification with least privilege. If you're building for defense or critical infrastructure, these guides are your blueprint. Since August 2025, FedRAMP has accelerated AI service authorizations by requiring zero-trust controls aligned with NIST AI RMF overlays. To earn the FedRAMP AI-approved stamp, a vendor must continuously verify agent identities, enforce least privilege, and segment AI workloads. Even if you're not selling to the government, you can use this same checklist as a battle-tested security baseline. It shows exactly what a secure AI deployment looks like. But here's the part almost everyone gets wrong. Most enterprises assume that if two agents are inside the same network or Kubernetes cluster, their handshake is safe. They don't authenticate that connection. Stamp that unchecked. That gap is exactly how lateral movement happens. A compromised agent can hop to another service with zero friction. In zero trust, every handshake must be verified, even between internal agents. Micro-segmentation forces agents to talk on a need-to-know basis. In this Kubernetes namespace, Agent A can only communicate with Agent B over mutual TLS. Every other path is blocked by network policy. Agent B cannot call Agent C, and Agent A cannot reach Agent C. Even inside the same cluster, there's zero implied trust. So if Agent A is ever compromised, the attacker can't pivot to other services. Old model. Agents inside the perimeter trust each other implicitly. No authentication, no authorization, static keys. The new Zero Trust fabric requires every connection to present a spiffy verified certificate, pass an authorization policy, and use an ephemeral token that's only good for that single request. That's the difference between a free-for-all and a verifiable mesh that contains an instant compromise. To enforce these policies, you need ZTNA tools that replace broad network access with identity-aware, per-application connections. Portnox delivers cloud-native NAC and ZTNA that treats every connection, even from an AI agent, as untrusted by default. Cloudflare Zero Trust offers identity proxy and per-app tunnels. Zscaler uses a SaaS platform to micro-segment traffic. These tools contain agent blast radius. If an agent is compromised, ZTNA ensures it can't reach anything beyond its authorized apps. Every agent needs a passport. With Spiffy, the secure production identity framework for everyone, an agent registers with a Spire server and receives a short-lived X509 certificate that carries a Spiff ID like Spiffy, Josh, Acme.com, Agent Josh fraud detection. When the agent presents that certificate to any resource, the policy engine verifies the identity cryptographically. No shared secrets, no static keys, just a continuously rotated, verifiable identity. Spiff and Spire are CNCF open-source projects that deliver this identity layer. Spiff defines the identity format. Spire automates certificate issuance and rotation across any environment. They eliminate the old world of long-lived static keys. Start with the Spire Quick Start to issue spiffy IDs to your agent pods. Every agent gets a verifiable, ephemeral credential that rotates automatically. Traditional access, a token generated a year ago with full read-write permissions, sitting in a config file. If it leaks, you're in trouble for months. Just-in-time access flips that. An ephemeral token is created on demand, valid for just 60 seconds, and scoped to a single operation, like performing a KYC lookup. Even if intercepted, the exploit window is tiny and the token auto-revokes. That's the difference between a permanent breach and a contained blip. Finally, intent validation. Does the request match the agent's mission? The policy engine doesn't just check identity. It classifies the purpose behind the request and compares it against the agent's behavioral baseline. If a fraud detection agent that normally queries only transaction logs suddenly asks for personally identifiable information, the engine denies the request and fires an alert. This stops authorized agents from being abused for unintended sensitive actions. Here's the mistake that actually costs people the job: thinking you can just give an AI agent a service account and hope for the best. OWASP calls it excessive agency, an LLM-enabled system with too much permission and autonomy, able to update database records, send emails, or call APIs without any human check. The fix is simple but non-negotiable. Separate the act of making a recommendation from executing it. If an agent needs to transfer funds, it should generate the draft. A human or a tightly scoped approval service signs it with a short-lived token. This week, inventory every agent in your environment and ask, does it both decide and do? If yes, you've got an excessive agency problem just waiting to become a breach. Every autonomous multi-agent system in 2026 needs a NIST SP 800-207 inspired architecture with 4 hard gates. First, ICAM for non-human identities. Every agent gets a verifiable identity, no anonymous service accounts. That identity feeds a central policy decision point that evaluates trust in real time. The PDP pushes decisions to policy enforcement points sitting at every API database and tool interface. And a continuous diagnostics and mitigation loop, CDM, keeps feeding behavioral telemetry back to the PDP so trust scores adjust dynamically. This is the only reference design that scales zero trust from a single chatbot to a swarm of 50 autonomous agents. And it's exactly what the DoD Zero Trust strategy requires for all AI-enabled systems by FY 2027. The heart of all this is a policy engine that never sleeps. Every request from an AI agent, whether it's reading a customer record, calling an internal API, or spawning a new sub-agent, hits 5 checks before it gets a green light. The engine looks at the agent's identity score, the posture of the machine it's running on, the classification of the data being touched, real-time threat intelligence feeds, and a behavioral baseline from user and entity behavior analytics. If any check fails, the request is denied or stepped up for human approval. This is what NIST cloud-native guidance means by explicit access controls. No implicit trust, ever. But here's the part. Almost everyone gets wrong. You can't protect what you can't see. Most orgs still have zero visibility into agent behavior patterns. Until an agent gets hijacked and suddenly starts exfiltrating data at 10 times its normal API call volume. That's the line you're looking at right now. The moment you set up a behavioral baseline in your SIEM, think Microsoft Sentinel or Splunk, and tie it to user and entity behavior analytics, you can spot that spike instantly. Set a rule. If an agent's API call pattern exceeds 300% of its rolling baseline, automatically revoke its OAuth token and quarantine its session. Don't wait for a human to notice. By then, the data is gone. Assume breach. Even with all the right policies, a determined attacker might compromise a single agent. The difference between a minor incident and a catastrophe is whether that agent is holding a long-lived credential. This shield is the answer: ephemeral tokens. Every access token for a production agent gets issued with a maximum lifetime of 30 seconds. The moment the agent completes its task, the token evaporates. So even if an attacker steals that token mid-flight, they have a window shorter than the time it takes to execute a single lateral move. This is just-in-time access for machines, and it's non-negotiable in the NIST cloud-native service mesh model. This isn't optional guidance, it's a compliance clock. The DoD Zero Trust strategy mandates a full zero trust posture across all DoD components by fiscal year 2027. That explicitly includes AI-enabled decision support systems and autonomous agents. Every contractor, every federal agency, every solution provider touching DoD AI workloads must have architectures like the one we just outlined. The demand for engineers and architects who can design these systems is about to explode. If you want to be the person who gets that call, start mapping your skills to the 5 pillars: identity, device, network, application, and data. Now, using the NSA Zero Trust Implementation Guides as your study playbook. When the auditors walk in, and under the CSA Agentic Trust Framework and CIS AI Security Companion Guides, they won't ask how your agents work. They'll ask for evidence. This is the hard artifact list. You need to produce agent identity certificates, signed policy decision logs, full token lifecycle tracking, the actual micro-segmentation configurations, behavior anomaly reports from your UEBA system, and cryptographic attestation that your enforcement points haven't been tampered with. Start generating these today. The auditors won't wait for you to build the pipeline. You don't have to build all this from scratch. Aegis Swarm is the Cloud Security Alliance's open-source reference implementation of the Agentic Trust Framework. It's a fully documented, deployable blueprint for zero trust across multi-agent swarms with the source code live on GitHub right now. Fork it, break it, study how it wires ICAM, PDP, CDM, and policy as code together. If you want hands-on experience with the architecture that DoD and major banks are mandating, starting with Aegis Swarm is the most career-relevant move you can make this quarter. The CIS Controls V8.1 Model Context Protocol Companion Guide, published April 2026, is the only mapping of established CIS controls directly onto MCP environments. If your agents use MCP tools, and in 2026 most do, every single server connection must be authenticated, tool access restricted per agent identity, every invocation logged, all traffic encrypted with mutual TLS, inputs and outputs sanitized, and rate limiting enforced to stop runaway tool calls. This is not optional. The MCP specification itself provides zero enterprise security controls, so the CIS Companion Guide is your immediate implementation roadmap. In a multi-agent development swarm, one agent writes the code, but a separate review agent, running under a different identity with zero write access, opens a pull request, checks it against security policy rules, and only allows a merge if the Zero Trust Policy Engine returns a clean approval. The policy engine evaluates the same continuous checks: identity, posture, data sensitivity, and behavioral baseline using an ephemeral token valid only for the duration of that review. Even if the developer agent is compromised, poisoned code can't merge automatically. This is how you put zero trust into your CI/CD pipeline. Never let one agent trust another's output implicitly. Here's a live banking swarm in 2026, micro-segmented with spiffy identities and ephemeral tokens. The fraud detection agent submits a read-only fraud score to transaction approval, but it cannot touch PII. That's cut off. KYC owns the PII, exposes only a verified customer flag. Transaction approval can authorize payments, but once the amount crosses $10,000, it must forward the request to a human for final approval. No token is permanent. No service trusts another just because they're inside the same VNet. Every call is authenticated and authorized against the NSA's Zero Trust Implementation Guides and the CIS MCP Companion Guide. The demand for professionals who can bridge zero trust and AI is growing fast. Organizations now need engineers who can stitch together spiffy, Entra-ID workload identities, and NIST SP 800-207 into an operational zero trust fabric. While exact figures vary, the need for these skills is skyrocketing as every enterprise deploying autonomous agents must build a security architecture that treats AI identities just like human ones. This is the skill stack recruiters search for in 2026. You don't need to check every box on day one, but the core trio of spiffy Spire, workload identity platforms like Entra-ID and AWS IAM, and the Zero Trust Blueprint NIST SP 800-207 will already put you ahead of 90% of candidates. Layer on the OWASP Agentic Top 10 list and agent log monitoring with a SIAM, and you're exactly the profile security teams are fighting over. All of this material is free. NIST SP 800-207 is a direct download. The CSA Agentic Trust Framework is a public blog post from June 2026. OWASP's cheat sheet lives on their wiki. The CIS MCP Companion Guide, by CIS, Sequence Security, and Asterix, is the only published mapping of CIS controls to MCP environments. Spiffy.io's library will have you issuing X509 identities to pods in an afternoon. And the Dr. Zero Trust paper spells out exactly how to adapt the 5 pillars Zero Trust model to autonomous agents. But here's the part. Almost everyone gets wrong. You don't need a production cluster to test this. In fact, you can build this entire Zero Trust agent environment on your laptop this afternoon for $0. 1. Spin up Minikube. 2. Deploy Spire, the reference Spiff implementation. 3. Launch an agent pod with a Spiff ID. 4. Write a Calico network policy so Agent A can't even see Agent B unless both present a valid identity. 5. Test mutual TLS. Handshakes fail immediately if the certificate isn't issued by Spire. 6. Ship the access logs into a lightweight SIEM like Elastic and watch what a denied request looks like. That's a half-day exercise that beats any theory blog. Here's what nobody tells you about internal agent traffic. It's the attack surface that gets breached the most often, and it's entirely preventable. The classic mistake. Agent A opens a raw gRPC call to Agent B inside the same virtual network and says, "We're inside the castle, so it's fine." It's not fine. The NSA's 2026 ZIGs extend Zero Trust to agent workloads, enforce mutual TLS, and identity verification for every connection, regardless of location. If Agent B's spiffy identity doesn't match the expected workload attestation, drop the connection before a single byte moves. That's the only handshake you should be offering. When you're securing an autonomous agent, a single overprivileged role is all it takes for excessive agency to turn into a headline. On the left, the old-school admin role. It can scan every table, modify records, and the API key never rotates. On the right, the least privilege model. The agent gets exactly one scope. Read the transaction table only. Zero write, zero access to PII. Its JWT lasts 60 minutes, issued and signed by a SPIF-backed identity provider, and the Cloud IAM policy enforces just-in-time elevation if it ever needs more. This is the pattern the CIS MCP Companion Guide recommends for every agent connecting to a data source. Static API keys are the security equivalent of leaving your house key under the doormat. If someone grabs it from a log file or a leaked repo, they become the agent. A Zero Trust approach binds every machine identity to a spiffy-issued X509 certificate. Spire attests the node, the pod, the image digest, and only then hands out a short-lived JWT. That token gets rotated automatically before an attacker can even brute force the signature. The CSA Agentic Trust Framework and NIST 800-207 drive this home. Machine identities must be bound to attestable credentials, not static secrets. Every agent starts with a trust score derived from spiffy attestation, network context, and historical behavior. If the behavior monitor sees the agent suddenly accessing a database it never touched before, the trust score engine recalculates and drops the number. The policy decision point checks against a policy based on the CSA Agentic Trust Framework, and if the score falls below a defined threshold, it immediately revokes the current token and forces step-up authentication. After remediation, the score climbs back, creating a continuous, adaptive loop. No static permit once for life, just machine speed Zero Trust. Data poisoning isn't just a training time threat. It's a runtime attack surface when poorly governed agents can write to the same pipelines that feed your models. Zero Trust shields you on 2 fronts. First, micro-segmentation via Kubernetes network policies denies any agent without a valid spiffy identity from even reaching the feature store. Second, identity validation makes sure that only a whitelisted model updater workload, the one signing its JWT with a hardware-attested Spire certificate, can push new training artifacts. The CIS MCP Companion Guide maps this pattern to relevant CIS controls, emphasizing rigorous identity validation and micro-segmentation as fundamental controls to prevent an agent-level compromise from poisoning the entire AI supply chain. You can't rely on humans to catch an AI agent going rogue, so you feed agent logs into a SIEM like Microsoft Sentinel. From there, user and entity behavior analytics detects anomalies, like an agent suddenly accessing a database it never touched. The playbook triggers, and SOAR automation instantly revokes the agent's OAuth token, containing the blast radius. This pipeline can go from alert to token revocation in under 2 minutes. Zero Trust isn't just a security play. It's a direct line to your bottom line. Cyber insurers increasingly evaluate your security architecture, and a documented Zero Trust posture aligned with NIST SP 800-207 and CIS controls can significantly strengthen your risk profile and potentially reduce premiums. To get budget, build a one-pager mapping your Zero Trust AI program to those frameworks. Carriers recognize that rigor, and it can open the door to better terms. The co-size overlays are being developed to bring AI-specific Zero Trust requirements into federal compliance, while FedRAMP's AI accelerated pathway continues to broaden. The Aegis Swarm framework from CSA is already maturing as an open reference. Top security architects are studying these now. Once they're mandatory, you're playing catch-up. For immediate action, bookmark the CSA Agentic Trust Framework and star the Aegis Swarm repository on GitHub to track changes as they happen. Look at this multi-agent system. Dozens of agents, each with API keys, chaining tasks, and passing data freely. There's no zero trust. If one agent gets compromised, it can laterally jump to any other service. Which principle do you apply first? The answer: implement SPIF identity. Give every agent a cryptographically verifiable workload identity using SPIF Aspire. Then enforce micro-segmentation so Agent A can only talk to Agent B on a specific API endpoint. That stops the implicit trust that gets whole swarms owned. You've seen the blueprint. Now get the step-by-step. Click the link in the description to grab the free IT career roadmap, and I've also dropped a bonus Zero Trust AI implementation checklist. It'll walk you through setting up a lab with SPIF Aspire, Microsoft Sentinel's free tier, and micro-segmentation rules so you can secure your first agent swarm this week. Start building today.